Hello guys, good morning to all of you. This is Maggi here, and now we are going to get discuss about the scattering of light and why the sun look like radish in color at the time of sunrise and sunset. So let me discuss here scattering of light. So according to the Rayligy, amount of scattering is directly proportional to the 1 by lambda power 4, where lambda is wavelength. ओके, सो रैले ने बताया कि जो अमाउंट ऑफ स्कैटरिंग है इज simply we can say that the fourth power inversely proportional to the fourth power of the wavelength, and this is written as like this: amount of scattering is proportional to 1 by lambda power 4. Okay, and we know that lambda r is greater lambda v, or simply lambda r is also equals to 1.8 lambda v. इतना लगभग जस्ट डबल होता है. ओके, so wavelength of the red color is more greater than with respect to the wavelength of violet color, or lambda r is equals to 1.8 times of the lambda v. So wavelength of red color is more greater than with respect to all the colors or violet color. So the according to this law of Rayleigh, scattering inversely proportional to the fourth power of wavelength. It means जिसका wavelength कम होगा और wavelength जिसका अधिक होगा उसकी scattering कम होगी. So here the much wavelength of red color and low wavelength of the violet. So here scattering of red color is very low and scattering of violet color is very high. Okay, so this is the scattering of light or Rayleigh's law. So according to the Rayleigh, amount of scattering inversely proportional to the fourth power of wavelength, or amount of scattering proportional 1 by lambda power 4, where lambda is wavelength, and we know that the wavelength of red color is greater than the all the colors, or greater than violet color. So here lambda r is equals to 1.8 times of lambda v. So according to this rule, the scattering or amount of scattering is very low of that colors whose wavelength is very high. So here red color's wavelength is very high. Due to this, its color scattering is very low, and wavelength of violet color is very low. Due to this, scattering or amount of scattering of this color is very high. Okay, and now why sun look like radish in color at the time of sunrise and sunset? So this is the earth. Okay, earth, and it is its horizontal position. So whenever sun at the horizon condition here, and whenever it is just midday or at the noon position, so this length is XA and this is XB. So here XA is greater XB, यानी इस लेंथ की कंपैरिजन में ये लेंथ बहुत छोटी है या ये लेंथ बहुत ज्यादा है. सो हियर ड्यू टू द Rayleigh's law, यहाँ पर जब स्कैटरिंग होगी तो सारे कलर्स की स्कैटरिंग सबसे ज्यादा होगी इन स्पाइट ऑफ रेड कलर. ओके, रेड कलर की स्कैटरिंग सबसे कम होती है. ये हमने स्कैटरिंग Rayleigh's रूल में डिस्कस किया. तो यहाँ पर देखिएगा, यहाँ से लाइट को अर्थ तक ट्रेवल करने में ज्यादा टाइम लगेगा. मींस वी कैन से दैट TA, and here time is TB. So simply we can say that TA is greater than TB. Okay, because स्पीड यहाँ पर फ्री स्पेस में सिमिलर होगी V. So here देखिएगा, यहाँ पर whenever sun is also at the position of horizon of the earth, means at the time of sunrise and sunset, so maximum colors will scatter in the atmosphere very fast. Only red colors This is a red color which is remains left at the surface of sun, which reaches at the ground or आफ्टर सम टाइम्स. ओके, यानी जितने भी कलर्स थे सन के आसपास वो सारे कलर्स पहले स्कैटर्ड हो गए, ज्यादा स्कैटर हो गए और एटमॉस्फेयर में चले गए. बट रेड कलर्स जो था वो इसके पास रहेगा ज्यादा देर तक, क्योंकि इसकी स्कैटरिंग कम हो पाती है, तो यही कलर अर्थ सरफेस पर पहुंच पाएगा. सो सिंपली वी कैन से दैट whenever sun situated at the horizon of the earth, it means at the time of sunrise or sunset, then all the colors get scattered in the atmosphere. Only red color remains left at the surface of the sun, so that red color also reaches up to the ground. Okay, with respect to all the colors, due to this reason sun look like reddish in color at the time of sunrise and sunset, and in this condition time taken is much than in this situation. Okay, so due to this reason sun look like reddish in color.